Hello dear students, welcome to the e-content development for the program of mechanical engineering and its allied branches, and it is for the subject of strength of material, for which subject code is 22306. This is very good initiative taken by the MSBT for all diploma students. Myself Yogesh Bhaskar faculty in Department of Mechanical Engineering, Kekewak Polytechnic, Nasik, welcome you all in this particular lecture. The topic that I am going to cover is a torsion, for which course outcome 5 is estimate stresses in shaft under twisting moment. So next, this is unit outcome number 2 and part number 2. Calculate torque and power transmitted by shaft in a given situation. The topic that I am going to cover in this lecture is torsion equation and basic concept, equation of power transmitted by the shaft, and problem based on the UO2. The key takeaways for this lecture are strength, power, twisting moment. The concept map is same as per the part number 1. Students should able to understand and apply the concept of power and torque transmitted by the shaft for the different field application. This is the torsion equation and basic concept. Again, we have covered this. This is only for your information, so you can go through it. Again, torque and power equation. The equation for power transmitted by shaft is as follows. Again, this is discussed in part number 1, but still P is equal to 2 pi nt upon 60, where P is equal to power in watt, T is equal to average torque, or we call it as a mean torque in Newton meter, and N is number of revolution of shaft per minute, that is RPM. So based on these all formulas which we are discussed in the part number 1, we are going to solve some problems. So first problem is calculate maximum torque that a shaft of 125 mm can transmit. Means a shaft of 125 mm can transmit if maximum angle of twist is 1 degree in a length of 1.5 meter. Take G is equal to modulus of rigidity is equal to 70 GPa. So this is the problem, and for solution of the problem, first we have to write down given data. So first, diameter of the shaft as it is given, D is equal to 125 mm. Then angle of twist, that is theta, it is given 1 degree. So how to convert 1 degree into radian? So 1 degree will be equal to pi by 180 radian. So we can convert it into radian. Length of the shaft L is equal to 1.5 meter. So convert it into mm. So it will be equal to 1.5 into 10 raised to 3 mm. Then modulus of rigidity G, or we can call it as a C, will be equal to 75 GPa, that is 75 kilonewton per mm square. But we have to convert it into Newton per mm square, that is 75 into 10 raised to 3 Newton per mm square. Let T, capital T, is equal to maximum torque the shaft can transmit. As we know that polar moment of inertia for a solid circular shaft is J is equal to pi by 32. Here is the pi by 32, D is not there. So pi by 32 into capital D raised to 4 is equal to pi by 32. By putting the value of diameter, we can find out value of J, 24.0 into 10 raised to 6. This is in mm raised to 4. And by using the relation of torque transmitted by the shaft, Tj is equal to G theta by L. So putting all the values in this above equation, we can find out value of T. So T will be equal to 0.814 into, in bracket, 24 into 10 raised to 6. So it will be equal to 19.5 into 10 raised to 6 Newton mm. So you can do the calculation and you can cross verify it. So answer will be equal to this torque will be equal to 19.5 into 10 raised to 6. This is in Newton mm, but we can find out in Newton kilo. We can convert it into kilonewton meter also. So it will be equal to 19.5 kilonewton dot meter. You can keep as it is also. So this is the answer that maximum torque that 125 mm shaft can transmit will be equal to 19.5 kilonewton dot meter. So next, second problem, find the maximum torque that can be safely applied to a shaft of 80 mm diameter, means diameter is given. The permissible angle of twist is 1.5 degree in a length of 5 meter and shear stress not to exceed 45 MPa. Take G, that is modulus of rigidity, is equal to 84 GPa. Again, in this particular condition, we have to find out the maximum torque, but we have two conditions. We can find out maximum torque on the basis of shear stress, and second on the basis of rigidity criteria. So first of all, see given data. Diameter of shaft is given 80 mm, angle of twist 1.5, convert it into the radian by multiplying it by pi by 180. Length of shaft 5 meter, it will be equal to 5 into 10 raised to 3 mm. Maximum shear stress, that is tau, or you can use Q also, it will be equal to 42 MPa, that is 42 Newton per mm square. Modulus of rigidity, again it is given in GPa, so convert it into MPa. So this is 10 raised to 3. This is 10 raised to 3. 84 into 10 raised to 3 Newton per mm square. So first of all, let us find out the value of torque based on shear stress and angle of twist. So first, based on the shear stress, we know that the torque which can be applied to the shaft, it will be equal to T1, it will be equal to pi by 16 tau into d cube. So putting all values of tau and diameter in this equation, we can find out torque on the basis of shear stress 4.22 into 10 raised to 6 Newton mm. So next, torque based on angle of twist. So we know that the polar moment of inertia of the shaft of solid circular shaft, J is equal to pi by 32 d raised to 4. So putting value of again diameter, we can find out polar moment of inertia, that is equal to 4.02 into 10 raised to 6 mm raised to 4. And as we know the relation of torque that can be applied, so T2 divided by J, it will be equal to G theta by L. So putting all values of G, theta, L and J in this equation, we can find out value of T2 by doing the calculation. You have to do the calculation with the help of calculator very carefully, because it will provide you the perfect marks in the final exam. If you not able to solve this particularly with the help of calculator, your answer may get wrong. So solve carefully. So T2 will be equal to 1.77 into 10 raised to 6 Newton dot mm. So now we have two values. We have two values of torque, one with the help of shear stress and second with the help of angle of twist. So for safe working, we shall apply lesser torque from the above two values. That is, T2 is the smaller value, it will be equal to 1.77 into 10 raised to 6 Newton mm. So this is the final answer, means a safer torque that a shaft can transmit will be equal to this one. So third problem, calculate the power of shaft of 300 mm diameter. Calculate the power of a shaft of 300 mm in diameter can transmit with a speed of 200 rpm if permissible shear stress is 120 Newton per mm square, and take maximum torque as 30% more than the average torque. So this condition is given. So diameter of shaft is given, rpm is given, diameter is equal to 300 mm, n is equal to 200 mm, and shear stress, that is tau, is equal to 120 Newton per mm square. And again, as per our discussion, maximum torque is given 30% than the average torque or mean torque. So T max is equal to 1.30 T mean or 1.30 T average. You can write in any way. So first of all, to find out power, first of all we know that T max is equal to pi by 16 into tau into d cube. So putting value of tau and d in this equation, we can find out the maximum torque, that is equal to 636172.5124 Newton meter. Step number second, as T max is equal to 1.30 times T mean. So T mean we can easily find out by doing the simplification. So T mean will be equal to, so T mean will be equal to 489363.47 Newton meter. And after getting this T mean or average torque, we can put in our power equation, and our power equation is 2 pi n T mean or T average divided by 60. So putting value of RPM, mean torque in this equation, we can find out power in the watt, that is 10249204.57 watt, and you can again keep in the kilowatt. So 10249.2 kilowatt. So this is the final answer, that a shaft can transmit power equal to 10249.2 kilowatt. Hope you understand all these problems to find out torque and power, how to find out torque and power with the help of given condition. So be ready for the next lecture, that is unit outcome number 3. Thank you.